Bismillahirrahmanirrahim. Assalamu alaikum dear students. This is our next video. As usual, we first come to statement of problem. Okay, sinusoidal waves 5.00 centimeter. First, dear students, it is to be noted here that sinusoidal waves amplitude is given in centimeter, while we are following MCAS system. So first we will convert this centimeter into meter by dividing it by 100, so it will become 0.05 meter. Okay, sinusoidal waves 5.00 centimeter or 0.05 meter in amplitude are to be transmitted along a string that has a linear mass density of 4.00 into 10 raised to power minus 2 kilogram per meter. Okay, the source can deliver a maximum power of 300 watt and the string is under a tension of 100 Newton. What is the highest frequency f at which the source can operate? Dear students, this is a little trick problem. Anyhow, when we will visit our relevant snapshots and visit various tables, etc., so things will become quite clear. Okay, as usual, we first come visit relevant snapshots. Okay, wave speed on stretched string. Wave speed on stretched string. The speed of a wave on a stretched string is set by properties of the string. The speed on a string with tension ta. Okay, this is a Greek letter tau, tension ta, and linear density mu is speed v is equal to square root or under root ta over mu. Okay, so this formula will be used in our problem to find out the speed of wave. Okay, now we move to next snapshot. Okay, dear students, this is next snapshot and this is a repetition of the above snapshot in a slightly different wording, having been chosen from some other book. Okay, the speed of a wave traveling on a taut string of mass per unit length mu and tension T is speed V equal to tension T over mass per unit length mu square root or under root. Okay, the same philosophy is repeated here which was shown in previous snapshot. The only difference is that here for tension instead of tau simply T is used. Okay, this is next snapshot. This is also a repetition of the same philosophy chosen from another book. Okay, speed of a wave on a string under tension. The speed of a pulse or wave on a string under tension can be found with the equation absolute value or modulus value or mod V is equal to square root or under root ft, where t is written as a subscript of f over mu, where ft T is written as a subscript of F is the tension in the string, and mu is the mass per unit length of the string. Okay, so dear students, all the above three snapshots have described similar philosophy, similar methodology. Okay, now again another version of the same. Okay, speed of a transverse wave on a string V is equal to square root or under root F over mu, where F is tension in string and mu is mass per unit length. Okay, in the presence of these four various snapshots on the same topic, a sense of confidence develops. Okay, this is a next proceeding in the problem, an advanced concept. Okay, advanced concept. Average power sinusoidal wave on a string P av, where av is written as a subscript of P, that is average power. Okay, average powers of a sinusoidal wave on a string P av is equal to half into square root or under root mu f, where mu is mass per unit length and F is tension in string, into omega square, where omega is wave angular frequency, into A square, where A is wave amplitude. Okay, so dear students, this expression is a little complicated, a little tricky, but it will solve our whole problem. We will just have to put the values in the expression and we will get our result. Okay, P av, average power of a sinusoidal wave on a string, is equal to half square root or under root mu f, where mu is the mass per unit length and F is the tension in string, into multiplied with square of the angular frequency of wave, wave angular frequency omega square, into square of the wave amplitude, that is capital A. Okay, now dear students, we see another snapshot. Okay, the power transmitted by a sinusoidal wave on a stretched string is P is equal to half mu omega square A square into V. Okay, this is almost a repetition of the above expression. Okay, here mu is the mass per unit length, omega is angular frequency, A is amplitude, V is speed. Okay, we will just put all values in this expression and our problem will be solved. Okay, now dear students, next is a table of physical constants. This table has also been used in our previous videos also. Okay, in this table we can see that expression in terms of SI units is given for various other quantities except radian, hertz, coulomb and magnetic field Tesla. Okay, means these four quantities have some specific ground due to which these units cannot be expressed in terms of SI units. Okay, these four quantities are radian, okay, which is a unit of plane angle, hertz, which is unit of frequency, and is equal to second inverse. Similarly, coulomb, it has also not SI units, equivalent SI units, and Tesla, magnetic field. Okay, now we move forward and see which snapshot is waiting for us. Okay, yes students, here again previous snapshot in a slightly different pattern, okay, having been chosen from some other book. Okay, the average power of or average rate at which energy is transmitted by a sinusoidal wave on a stretched string is given by P average is equal to half mu V omega square y m square, where m is written as a subscript of y. Here m stands for maximum. Okay, mu is mass per unit length, v is speed, omega is angular frequency, etc. Okay, now we see another snapshot. Dear students, this snapshot is about angular wave number and period and time period and frequency. Okay, the angular wave number k and angular frequency omega of a wave are defined as follows: k 3 lines 2 pi over lambda. Lambda is wavelength. 2 pi is always associated with radian. 2 pi radian. 3 lines denote that it may be treated as k is equal to 2 pi over lambda, or k is defined as 2 pi over lambda, or k is equivalent to 2 pi over lambda. Okay, these 3 lines convey such understanding, such meaning. Okay, moreover, angular frequency omega is equal to 2 pi over t. T is time period, and is equal to 2 pi f, because we know that frequency and time period are reciprocal of each other. 1 over tau is equal to f, and 1 over f is equal to tau, where tau is the period of the wave and f is its frequency. Okay, this expression will also be used in solving our problem. Now this is the next snapshot. Okay, this snapshot says angular frequency omega related to frequency and period. Okay, angular frequency omega is equal to 2 pi f, where f is frequency, and this is alternatively equal to 2 pi over t, where t is time period. Okay, almost the same concept has been repeated in previous snapshot. Okay, now this is some information about angle. 1 radian is equal to 57.30 degree, and this alternatively becomes equal to 180 degree over pi. 1 degree is equal to 0.01745 radian, and this is alternatively equal to pi over 180 radian. 1 revolution is equal to whole circle, that is to say 90 degree first quadrant, 90 degree second quadrant, 90 degree third quadrant, 90 degree fourth quadrant. 4 into 90 equal to 360. Okay, so 1 revolution equal to 360 degree, and this is equal to 2 pi radian. That is why wherever in calculating angular measurements 2 pi is involved, we add radian with 2 pi from ourselves. Moreover, this radian often causes a confusion in the adjustment of units of various quantities. That is why we adopt the process that we take quantities without their basic units. However, we take all the quantities in MKS system and we simply calculate the quantities without their units, and last the resultant quantity which comes as a result is also expressed in MKS system. Okay, for example, if we are going to find out length, it will be in meter. If we are going to find out speed or velocity, it will be in meter per second. If we are going to find acceleration, it will be in meter per second square, etc. Okay. Similarly, 1 revolution per minute RPM is equal to 0.1047 radian per second. This is also some information about angle. Okay. The SI supplementary units: plane angle radian, symbol RAD, rad. Solid angle T radian, symbol SR. Now, purpose of this snapshot is just to ensure that value of pi is 3.14159. We usually take it up to 2 decimal places, that is 3.14 only. Okay, dear students, again some more information about trigonometry, because here, dear students, actually radian causes confusion if we use units of various quantities. Okay, definition of angle in radian: theta equal to S over R. 2 pi radians in complete circle, 1 radian equal to 57.3 degree. Dear students, then once again, angle phase, this information has already been discussed in previous snapshot. Now we are going to solve our problem in a regular manner. Okay, in a regular manner, we reduce first we reduce its size a little. Okay, yes, this is okay, this is okay, this is okay. Okay, using speed V equal to tension tau over mu, mass per unit length. Okay, with tension T equal to 100 Newton and mu equal to 4.00 into 10 raised to power minus 2 kilogram per meter. Okay, these two quantities are provided in the problem statement. We are just using them in this formula. V equal to tau over mu. Tau is 100 Newton, while mu is 4.0 into 10 raised to power minus 2 kilogram per meter. Okay, dear students, in the next step, because 10 raised to power minus 2 is in the denominator, it will be shifted to numerator and it will become 10 raised to power plus 2. So 100 when multiplied with 100, it will become 10,000. So in the numerator we will get 10,000 Newton. Moreover, in the denominator, mass M, meter, kilogram per meter. Meter is appearing in the lower part of denominator, so it will be shifted to numerator. That is to say, 10,000 Newton into meter divided by 4.00 kilogram. Okay. In the next step, what we have done, we have converted Newton into its alternate units as kilogram meter per second square. Kilogram meter per second square, 1 meter is already present, so it will become kilogram into meter square. And kilogram, this kilogram is already present, and while the second square will be of Newton. We have replaced Newton by its alternate units, so we have get the expression as kilogram meter square per kilogram second square. Here kilogram will be cancelled from kilogram, kilogram will be cancelled from the numerator as well as denominator, and we will get 10,000 over 4 meter square over second square whole square root or under root. Dear students, simply meter square over second square will become simply meter per second when taken out of square root or under root. Similarly, 10,000 when divided by 4 and then taken under root, it will become 50. So our speed will become 50 meter per second. This is a solution of one part. Okay. Now we move to a little complicated part of this problem. Okay. Using P equal to half mu angular frequency omega square, amplitude a square, speed v, okay, where P is the power transmitted by a sinusoidal wave on a stretched string, mu is the mass per unit length of the string, omega is angular frequency, a is amplitude, and v is the wave speed. Okay, everything is given, formula is clear. We have just put the values in this formula and we are going to solve our problem. Okay, so this is 300 Newton meter per second equal to 1 by 2 4.00 into 10 raised to power minus 2 kilogram over meter into omega square into 5.00 into 10 raised to power minus 2 meter square into 50.0 meter per second. This is 50.0 meter per second is that value which we have calculated in previous step. This is 50 meter per second. Okay, this is 50 meter per second. This is that value which we have calculated in previous step. While this value is given in the statement 5.00 into 10 raised to power minus 2 meter square. Moreover, 4.00 into 10 raised to power minus 2 kilogram per meter. This is also provided in the statement. This is 300 Newton meter per second. This is also given in the statement. Okay. From here we have to find out the value of omega. Okay. First we will find the value of omega square. Then we will take square root on both sides, and hence we will get the value of omega. So 300 Newton meter per second equal to 0.00 kilogram per meter. Okay. How this value becomes? Actually, when we will divide 4 by 2 and then multiply it with 5.0, so it is the next step is just simplification, nothing else. These simplification steps belong to almost primary school level or middle school level, secondary school level. Okay, anyhow. 300 Newton meter per second is equal to 0.0025 kilogram meter square over second into omega square. Okay, into omega square. This implies that if we keep omega square on one side, then 300 Newton per second, this is as it is already existing. Now remaining factor, multiplying factor with omega square, will be shifted to other side of equality with the properties that denominator will become numerator and numerator will become denominator. Reverse. Okay. So omega square has become equal to 300 Newton meter per second into second over kilogram meter square into 1 over 0.0025. Anyhow, omega square equal to, after simplification, it becomes 12 with 4 zeros Newton over meter kilogram. This becomes equal to 12 into 40 kilogram meter per second square into 1 over meter kilogram. What we have done, we have replaced Newton by its alternate units. Okay. We have shown this table several times in our previous videos, that Newton can be written expressed as its alternate units kilogram meter per second square. Okay, so anyhow, when we replace Newton by its alternate units, then kilogram will be cancelled from numerator and denominator. Similarly, m will also be cancelled in the denominator and numerator, and we will get 12 with 4 zeros divided by second square. This is the value of omega square, square of the angular frequency, but we are concerned with simply angular frequency, so we will take square root or under root on both sides. So omega will become equal to 346.41. Dear students, here radian does not appear. Its answer will be only 346.41 second inverse, that is hertz. But we know that unit of angular frequency are radian per second, because wherever angle is involved, radian is involved. Okay, so unit of angular frequency are always radian per second. Okay, so here we have from ourselves used radian, otherwise its answer was 346.41 second inverse or hertz, but we have mentioned it as radian per second because this frequency is not simple frequency, this is angular frequency, and unit of plane angle is radian, so we have added radian from ourselves. Now omega angular frequency is equal to 2 pi f. From here this implies that f will be equal to omega over 2 pi. We have found omega in previous step, which was 346.41 radian per second over 2 pi, 2 into 3.14. Here, dear students, once again, because I have mentioned many times that 2 pi is always associated with radian while calculating angular frequency or angular measurements. So we have from ourselves added rad with this 2 pi, so that this rad will be cancelled with above rad in the numerator, and our answer will appear only in terms of second inverse, which is equal to hertz. So our answer becomes a frequency equal to 55.16 hertz or second inverse. This is the end of our video. This is the end of our problem. Till next video, till next problem, till next video. Allah Hafiz.